Alright, so today's screencast is on perpendicularity of a line and a plane. Fun stuff. More plane stuff. So your learning goals. You will be able to recognize when a line is perpendicular to a plane, and you will be able to apply the basic theorem concerning the perpendicularity of a line and plane. Simple stuff. This will be a fairly short. A line perpendicular to a plane. So what is meant when we say that a line is perpendicular to a plane? How does that look? How do you imagine that? We kind of touched on it a little bit the other day. But the definition is a line is perpendicular to a plane if it is perpendicular to every one. This is the important part. Every one of the lines in the plane that pass through its foot. So every one of the lines that are in the plane. Okay, so that's also important. And it's that pass through its foot. So for example, we've got, I picked a bad color to use for this. So we've got this plane here, and for instance, we have line EB, line BC, segment, whatever you want to call it, line BD, and then this line A here. All right, so we have two kinds of perpendicularity now. We have perpendicularity between two lines, such as between AB and BD, so this would be perpendicular here, as well as between a line and a plane. So line AB and plane M are perpendicular. Additionally, we can say that, going along with number one, we could also say that line AB is perpendicular to BC. We could also say that line AB is perpendicular to EB. Okay, so you get the idea. We've got additional line segments because all three of those lines are on plane M. Alright, so now the basic theorem concerning perpendicularity of a line and a plane. So, for instance, if a line passed through a plane, what do you think the minimum number of lines that it would have to be perpendicular in order to say that it was perpendicular to the plane? So we're talking about how many lines would a line passing through a plane have to be perpendicular to in order to say it was perpendicular to the plane. And the answer is stated in Theorem 48, and it says if a line is perpendicular to two distinct lines that lie in a plane, so both of them have to lie in a plane, there has to be two or more, and pass through its foot, then it is perpendicular to the plane. So it has to be perpendicular to two lines lying on the plane, and those lines have to pass through its foot. Okay, so here's an example of what that looked like. Here's line BF and line CF, and if we said that line AF was perpendicular to both of those, then we could say that line AF is perpendicular to plane M. Alright, so let's do some proofs with these, some examples. So we're given that segment PV bisects segment TS, and we're given that line TS is perpendicular to plane M. And we want to prove that ray PV bisects angle TPS. So first we'll state our givens, get that out of the way. And let's run with, we'll start with this one right here. So we're going to say that segment TS is perpendicular to segment PV, and that's because of the theorem we just learned about. If a line is perpendicular to a plane, then it is perpendicular to every line in the plane that passes through its foot. So then we can say that angle TVP and SVP are right angles because perpendicular lines form right angles. We could then say that those two angles are congruent because all right angles are congruent. We could say that TV is congruent to VS because a bisector divides a segment into two congruent segments. So we know that, let's go ahead and mark up the diagram. So we know that these angles are right angles and congruent because TS is PV bisects TS. We know that those two are congruent. We also know that PV is congruent to PV by your favorite property, reflexive property, which allows us to prove triangle TVP and triangle SVP congruent by side angle side. And then we can say that angle TPV and angle SPV are congruent because of CP-CTC, which then by the definition of angle bisector, we could show that ray PV bisects angle TPS, because if a segment divides an angle into two congruent angles, it is the bisector of the angle. Pretty simple stuff. A lot of steps in that one, though. It's pretty indicative of what you're going to be facing going on. Let's take a look at another example, and I kind of want you to try this one on your own before you actually go through and look at the solution. So you're given that B, C, D, and E lie in plane N, that segment AB is perpendicular to N, and that line BE is the perpendicular bisector of segment CD. And we need to prove that triangle ADC is isosceles. So again, we need to think three-dimensionally here. So we start off with using this one first, so we can cross that one off the list. Segment AB is perpendicular to N. That's a given. What is that going to tell me? Well, that'll tell me that AB is perpendicular to BD, and AB is also perpendicular to BC, because of, if a line is perpendicular to a plane, it is perpendicular to every line in the plane that passes through its foot. We can then say that those two angles are right angles, because perpendicular lines form right angles, which allow us to say that angle ABC is congruent to angle ABD, because right angles are congruent. Then we can say that line BE is the perpendicular bisector of CD, which is also given. Okay, which tells us that BC and BD are congruent, because if a point is on the perpendicular, remember, this goes back. If a point is on the perpendicular bisector of a segment, it is equidistant from the segment's endpoint. So we need to go back to that one. We can also say that AB is congruent to AB because of the reflexive property. Now we can say that triangle ABC is congruent to triangle ABD because of side angle side. And then our old pal CPCTC comes into play, AD and AC, which would give us that triangle ADC is isosceles, because of the definition of an isosceles triangle. It states a triangle with two congruent sides is isosceles. So a lot of stuff kind of coming up from the past here, so it just shows the importance of remembering your theorems. I will do my best to make sure that you start using some of the ones that you may not have used in a while. But in the meantime, just again, the hardest part about this is trying to think three-dimensionally. So work on that. If it helps, break it up into pieces. If you have any questions, as always, ask me in class the next time you see me. Have a good one.